Have you ever stood at the base of a skyscraper, looked up, and just wondered, how on earth did they build that? How did they get materials, steel beams, and giant glass panels all the way to the top of something like the Burj Khalifa? It seems almost impossible, like a magic trick. Well, it's not magic, it's engineering, and the secret lies in some of the most incredible machines ever built. Tower cranes. These aren't just any cranes. They are the unsung heroes of the skyline, the giants that build other giants. Today, we're going on a journey to the top of the world. We're going to uncover the fascinating technology behind how these colossal cranes build our tallest skyscrapers. It's a story of incredible ingenuity, mind-boggling physics, and a little bit of nerve. Stick around, because by the end of this, you'll never look at a city skyline the same way again. So, let's start with the basics. The main workhorse of any super-tall skyscraper construction is the tower crane. You've definitely seen them. Those tall, slender metal structures that dot the city landscape. But how do they get up there in the first place? They don't just magically appear hundreds of meters in the air. The process is called climbing, and it's one of the most brilliant pieces of engineering you'll ever see. Initially, a mobile crane is used to assemble the base of the tower crane. This base is anchored to a massive concrete foundation, sometimes weighing hundreds of tons, to ensure it's completely stable. The mobile crane then lifts the first few sections of the crane's mast, the vertical tower, into place. It also lifts the slewing unit, which is the part that rotates, the operator's cab, and the jib, which is the long horizontal arm. Now, here's where the magic happens. Once the crane is assembled to a certain height, it starts to build itself. This process is called self-climbing. The crane uses a special climbing frame, or a top climber, that surrounds the mast. When it's time to go higher, the crane lifts a new mast section from the ground up to the climbing frame. The frame, using powerful hydraulic rams, pushes the entire top part of the crane, the slewing unit, cab, and jib up by one section. This creates a gap in the mast. The new mast section is then slotted into this gap and bolted securely into place. Who's like that? The crane has grown taller. It repeats this process over and over, essentially pulling itself up by its own bootstraps as the building grows beneath it. For really tall buildings like the Burj Khalifa, they used several specialized cranes. The main players were high-capacity Favco cranes, known for their incredible lifting power and speed. At the peak of construction, there were 3 of these cranes working on the central spire. They didn't just climb on their own. They were also anchored to the building's core structure at various levels. These brace points provide crucial stability against the wind, which is a massive force at those altitudes. Think about the operator sitting in that tiny cab, over 800 meters in the air. Their view is breathtaking, but the responsibility is immense. They are precision operators, lifting tons of steel and concrete with millimeter accuracy. They communicate constantly with the team on the ground, known as riggers and dogmen, who attach the loads and give signals. It's a perfectly choreographed dance happening hundreds of meters above the city. But what about the power? How do these machines lift such heavy loads? It all comes down to a system of motors, gearboxes, and steel cables. The main lifting is done by the hoist, a powerful electric motor and winch drum located at the back of the crane, on the counterjib. This counterjib also holds massive concrete counterweights to balance the load being lifted on the main jib. It's a simple principle of leverage, the same one you learned in school, but on an epic scale. The further out the load on the jib, the less weight the crane can lift. This is all calculated precisely by the crane's computer system, called the load moment indicator, which prevents the operator from lifting a load that could tip the crane over. The engineering doesn't stop with the cranes. Building a skyscraper is a symphony of different technologies working together. You have concrete pumps, for instance. For the Burj Khalifa, they had to develop some of the most powerful concrete pumps in history. These machines pushed a special mix of high-strength concrete up to a record-breaking height of over 600 meters. Pushing a thick, heavy slurry that high is an incredible feat of hydraulic power. The concrete itself was a special mix, often poured at night when the Dubai temperatures were cooler, to ensure it cured properly. They even added ice to the mix. Then you have the formwork systems. These are the molds that shape the concrete floors and walls. For skyscrapers, they use self-climbing formwork. Similar to the cranes, these systems use hydraulic jacks to lift themselves up from one floor to the next, after the concrete is set. This allows for a very fast and repetitive construction cycle. A new floor can be completed every 3 to 4 days. This incredible speed is how these giants seem to sprout from the ground so quickly. Let's also talk about the unsung heroes, the engineers and workers. The level of planning that goes into a project like this is mind-boggling. Structural engineers use sophisticated computer models to simulate everything from wind loads to earthquake resistance. Every single steel beam, every bolt, every pane of glass is planned for. The logistics are like a military operation. Thousands of workers, speaking dozens of different languages, have to coordinate their efforts perfectly. Safety is the #1 priority. Working at these heights is inherently dangerous, so safety systems, harnesses, nets, and strict protocols are absolutely essential. Now for the final puzzle. Once the skyscraper is complete, how do they get the cranes down? You can't just leave them up there. Well, the process is basically the reverse of how they went up, but with a twist. The highest crane is used to dismantle a lower crane. Then, a smaller crane, often called a derrick crane, is assembled on the roof. This smaller crane is used to dismantle the last tower crane, piece by piece, lowering each section to the ground. Once the main tower crane is gone, you're left with a small derrick crane on the roof. So how does that get down? This is the coolest part. This small crane is designed to be taken apart into pieces small enough to fit inside the building's own service elevator. The crew disassembles it, takes it down the elevator, and walks it out the front door. It's an ingenious and surprisingly simple end to a complex process. So, the next time you marvel at a super tall skyscraper, think about the incredible journey it took to get there. Think about the self-climbing cranes that build themselves, the powerful pumps that pushed concrete to the clouds, and the thousands of skilled people who orchestrated this massive construction ballet. These buildings aren't just structures of steel and glass. They are monuments to human ingenuity, ambition, and our relentless desire to reach for the sky. It truly shows that with the right tools, the right team, and a big enough dream, almost anything is possible. Thank you so much for joining me on this deep dive into the world of skyscraper construction. If you found this as fascinating as I do, make sure to hit that like button and subscribe for more videos where we explore the amazing engineering that shapes our world. Let me know in the comments which megastructure you'd like to see us cover next. Until then, keep looking up.